Hello class. Today I'm going to discuss section 6.1, 6.2, and also 6.3. Okay? I will discuss section 6.1, 6.2, okay, and also section 6.3. Okay? Let's see how far we get. I'm going to try to discuss up to section 6.3. If I can't, I'll discuss it next time. Okay. So in 6.1, we're simplifying rational expressions. And what is a rational expression? What is a rational expression? Think of rational expressions as fractions. Yes. Fractions with x in the denominator. So here is a fraction. Five over 7. That's a fraction. If I put a variable in the denominator, then we can call it a rational expression. The same thing. 5 over 7x. That's a rational expression. Okay? So basically, think of rational expressions as fractions. Now, we know how to simplify fractions. So we can employ the same concept for rational expressions. For example, watch this. Simplify. Simplify I'm going to say 12 divided by, I'm going to say 32. Okay. Let's do it the long way. Why? Because if we do it the long way, we can use what we learn in simplifying rational expression. Notice here we are simplifying a fraction. Simplify the fraction. Let's do it the long way. And what's the long way? The long way is to take the numerator and find its prime factorization, take the denominator and find its prime factorization. That's the long way. I want you guys to do it the long way. And there's a reason for it. So what is the prime factorization? The long way is the prime factorization of numerator and denominator. That's the long way. Okay? And that's okay, don't worry about it. Okay? We're going to learn from this. We're going to learn from this to simplify rational expressions. Okay? So, what's the prime factorization of 12? Well, 12 is 4 times 3. And 4 is 2 times 2. So 12 2 times 2 times 3. No, they are all primes. That's why it's called a prime factorization. Prime factorization. 32. 32 is 2 times 16. 16 is 4 times 4. So 32 equals 2 times 16. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So therefore, 2 times 2 times 2 times 2 times 2 is 32. That's the prime factorization. Prime factorization. Now, the fun part. We're going to simplify. So this one cancels that one. This one cancels that one. And what do we get? We get 3 over 8. You're asking yourself by now, why is it doing this the long way? We don't have to, right? You're thinking, we don't have to. I know that 4 goes into 12, and I know that 4 goes into 32. You're right. The problem is that I'm trying to learn something so that I can apply it to rational expressions. And we did. What did we learn? We already knew it, but we learned something that we can apply next. The long way, we learned that we can simplify the long way. How? The prime factorization of the numerator and the prime factorization of the denominator, and then cancel common factors. Yeah. Therefore, we can apply this to the following. Consider the following. Consider the following concept. Oh, this is beautiful. Look at this. Watch this. X squared minus 9 divided by 5x squared minus 15x. Yep. And let's simplify. Let's simplify this rational expression. Hey, we learned something here. We learned. We can, if we can simplify that, we have no choice there. Let's do it the long way. And what's the long way? Let's do the prime factorization of the numerator and the prime factorization of the denominator. Okay. Now, you have to factor the top. Who knows how to factor the top? Well, we can factor the top. The first step in factoring is to take out the greatest common factor. In the top is 1, so it doesn't change anything. And then the second step is to look at the top and see, wait a minute, that's a difference of 2 squares. So we can factor this. This is x minus 3 times x plus 3. That's the top. Yep. And that's the prime factorization of the top. Okay? That's the prime factorization of the numerator. What's the prime? Notice, 2 factors. What's the prime factorization of the denominator? What's the first step in factoring? Take out the greatest common factor. What is the greatest common factor in the denominator? We can take out a 5 and an x. So denominator, take out a 5, x times x minus 3. Hey, Look! 5x times x is 5x squared. 5x times negative 3 is negative 15x. And now, here we cancel common factors. Note, in the numerator we have 2. In the denominator, we can say we have 3. A 5, an x, and an x minus 3. Okay? And look guys. This x minus 3 cancels this x minus 3. And what's our answer? X plus 3 divided by 5x. Note, this x does not cancel that x because this x is not by itself. This x belongs to x plus 3. So they do not cancel. That's the answer. You see, I told you we can learn something from this. Let's do it again. Factor the following. Okay, let's factor the following. Simplify the following. How's that? Simplify. 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 28x to the 4th divided by 7x to the 5th minus 14x squared. Okay. Well, you have no choice but to do it the long way. The long way is the prime factorization of the numerator and the prime factorization of the denominator. Well, let's do that. Let's get the denominator first, okay? Denominator. In the denominator, what can you factor out first? Let's take out a 7x squared. The 7x squared comes out times what? X to the 3rd times what? Minus 2. Oh, now the top. You see the 7? In the top, 28. 7 goes into 28. Okay? But first, let's factor 28. And let's use a factor of 7. So 28 is 7 times 4. That's 28. This 4 is not going to cancel. You see this x to the 4th? I see x squared below. So x to the 4th is x squared times x squared. All right. So a 7 cancels the 7. And x squared cancels the x squared. Okay. This x squared does not get canceled. This 4 does not get canceled because you see this 2 belongs to this factor. This 2 belongs to x cubed minus 2 factor. And you cannot break them apart. Just like here, you cannot break this x plus 3 apart. You cannot cancel this x and that x. Because this x plus 3 belongs together. It's a factor. It was a factor from the very beginning, look. So you can't break them apart. So what's the answer for the bottom? The answer is going to be what? 4x squared divided by what? Divided by what? X cubed minus 2. There you go. Yeah. And that's how we simplify. Simplify the following. Simplify the following, class. Simplify this, look. Simplify. Simplify x squared minus 6x plus 9 over 6x squared minus 18x. Simplify. Okay. And then simplify this also. Simplify this. Simplify. Simplify 2b squared plus 7b minus 15 divided by 2b squared plus 13b plus 15. Okay? Gotta erase that, okay? Have to erase this, guys. Okay. Let us simplify. No problem. Let's factor the top. Prime factorization. That's x squared, that's x times x, and 3 times 3, and this is minus and minus. So x times x is x squared, negative 3 times negative 3 is positive 9, and outer is negative 3x, inner is negative 3x, negative 3x plus negative 3x is negative 6x, which is right there. The bottom, factor out of 6x times what? Times x minus what? Minus 3. Look at that. And then, maybe in red, this x plus 3 cancels this x plus 3. And what do we get? The answer is x minus 3 divided by 6x. And do not cancel the 3 and the 6 because this 3 belongs to x minus 3. Look, from the very beginning, x minus 3, and they cannot be broken apart. No, you can't. You can't just put them apart. They go together. Let's do the bottom. Bottom. Factor the top. Okay, take out the greatest common factor, which is 1. It doesn't make a difference. For this 2b squared, I'm going to say 2b times b. That's 2b squared. From this negative 15, can I just say 3 times 5, right? 3 times 5 is 15. So 3 times 5 is 15, and I'm gonna make this, you see this 10? This 2 times 5 is 10, I'm gonna make it plus, and I'm gonna make this minus. And I'm gonna check now. So 2b times b is 2b squared, negative 3 times 5 is negative 15, yes. And then outer is 10b. 10b minus 3b is 7b. And look, 2 factors, 2b minus 3. This is 1 factor. They cannot be broken apart. And b plus 5. They're together. They cannot be broken apart. So here we have two factors. Bottom. Factor again. 2b squared, I'm going to say 2b times b. For 15, I'm going to say 3 times 5. Again, 3 times 5. Because this is plus, they're both plus. And now I'm going to check. So 2b times b is 2b squared. 3 times 5 is 15. Outer is 10b. Inner is 3b. 10b plus 3b, 13b. Okay. Okay. This cancels that. And what do we get? We get 2b minus 3 over 2b plus 3. Please do not cancel the 2b's. Don't do that, because this 2b minus 3 is together. It cannot be broken apart. So therefore, this 2b and this 2b cannot be canceled. All right. Now, if we ever have to multiply two fractions, no problem. Watch this. Consider the following. Multiply and simplify. Watch this. 24 divided by 25 times, I'm going to say 15 divided by, I'm going to say I'm going to say 28. There you go. I know you guys know how to do it fast, but let's do this the long way. And there's a reason why. Okay? There's a reason why. Again, just like before. I'm just not doing this for fun. I'm going to do it the long way because I'm going to show you something. So this has to go. See, I'm getting my wall dirty. All right, let's do it the long way. Here's the long way. The prime factorization of numerator and denominator. Just like before. So take this and do a big fraction and take the numerator and do the prime factorization. What's the prime factorization of 24? 24 is 8 times 3. This 24 is 8 times 3. And 8 is 2 times 2 times 2, and then times 3. That's 24. 15 is 3 times 5, times 3 times 5. So here we have the prime factorization of the numerator. Yes, 24 times 15. Now let's find the prime factorization of the denominator. 25. What's 25? 25 is 5 times 5. What about 28? 28 is 4 times 7. 4 is 2 times 2 times 7. There you go, guys. So now I have the prime factorization of the numerator and the prime factorization of the denominator. And now I am ready to simplify. So this 2 cancels this 2. This 2 cancels this 2. Yes? This 5 cancels this 5. Is that it? I think so. I think that's it. And so now, the numerator is what? 2 times 9, 18. And the denominator is what? 5 times 7, which is 35. There you go. I know that's the long way, but there's a reason why. And here's the reason. Watch this. Okay. Consider the following. Oh, look at this one. This one, look at this one. Simplify, multiply and simplify. That's the way it says. Yes, multiply and then simplify. Look at this one. 8 to the 4th plus 6a cubed divided by a square minus 16 times 3a minus 12 divided by 3a plus 18. Okay? Well, let's do the prime factorization of the numerator first, and then the prime factorization of the denominator. So let's make a big fraction. Big fraction. And let's do this one first. How do we do this one? Take out an a cube. A cube times what? Times a plus 6. That's the first one. How about this one? Take out a 3. No, don't forget, it's multiplication, okay? So times 3 times a minus 4. Got the top. Now let's do the bottom. How about that one? Difference of squares. A times a, 4 times 4, plus and minus. That would be that one. But this one times 3 times a plus 6. So in the numerator, you have 1, 2, 3, 4 factors. In the denominator, we have 1, 2, 3, 4 factors. A plus 4 is a factor together. They cannot be broken apart. A minus 4 is a factor together. A plus 6 is a factor together. A plus 6 is a factor together. Okay? So, this a plus 6. Look, a plus 6 cancels a plus 6. That's okay. A minus 4 cancels a minus 4. That's fine. And what are, oh, the 3 cancels the 3. So what's left behind? A to the 3rd divided by a plus 4. Can I cancel an a with an a? No, because we just said that this a is not by itself. This a belongs to a plus 4. Look, it belongs to a plus 4. So do not cancel an a from here with an a from there. Wrong if you do that. Now, okay. If you ever have division, no problem. Division is no problem. Watch this. Watch this, guys. Divide and simplify. Right there. Okay. Wait a minute. Let me give you an example. Watch this. 21 divided by 35 divided by 14 divided by 45. Okay, I've got to erase this one, okay? Okay, so you guys by now you should know that when we divide, we multiply by the reciprocal. So let's take this let's take the reciprocal of this fraction to the right. So this equals to 21 over 35, and then multiply times the reciprocal, 45 divided by 14. And now, do what we did earlier, seconds ago. Factor the top, the prime factorization, and factor the bottom. In the top, we have 3 times 7, and 45 is 3 times 3 times 5, that's 45. In the bottom, we have 5 times 7, and then we have times 2 times 7. So that's 35, and that's 14, and they're being multiplied, look. And now we can cancel. The 7s cancel. The 5s cancel. Is that it? I think so. I think that's it. And what do we get, guys? What do we get? 3 times 3 times 3, which is what? 27. Divided by what? 2 times 7? 14. Okay. I am going to do problem number 57. Problem number 57. Okay? On 6.2. 6.2, number 57. This is what it says. It says a squared minus (18a plus 81). 18a plus 81 divided by a to the 40th divided by a minus 9 to the 3rd, that's a 9, divided by a to the 37th. Okay. Okay, no problem. Well, let me go, yeah, let's go below. So let's multiply by the reciprocal. A squared minus 18a plus 81 divided by a to the, is it 40th? Yes. A to the 40th times, this goes up, a to the 37th divided by a minus 9 to the third. Okay? And now I'm gonna factor the top. So in the top, we have this big fraction. I'm gonna factor this one, product of binomials. So that's an a times a. And that's a 9 times 9. And that's a minus and a minus. You see this a to the 40th? A to the 40th is a to the 37 times a to the third. And why am I using a to the 37? Because in the top we have a to the 37. You see that? If you multiply a to the 37th times a to the third, you add the powers. And what's 37 plus 3? 40. Okay? I'm doing the denominator. The numerator has those two, and then a to the 37th. So the numerator, you factor this, and you keep that one. In the denominator, I see this a to the 40th, but a to the 40th, I'm going to try to cancel a to the 37th, so I say a to the 40th is a to the 37 times a to the third. And this one here is a minus 9 to the third. Okay? All right. Guys, this a minus 9 times a minus 9, that's a minus 9 to the second. I tell you right now, this a to the 37th cancel this a to the 37th. Yes, it does. And you see this a minus 9 to the second, and in the denominator you have a minus 9 to the third. Watch this. In the numerator you have a minus 9 to the second. In the denominator you have a minus 9 to the third. But a minus 9 to the third is a minus 9 to the second times a minus 9. That's a 9. And watch this. Don't forget, times a 1. This a minus 9 to the second, cancel this a minus 9 to the second, and what do we get? 1 over a minus 9. That's your answer. 1 over a minus 9. That's a 9, okay? Looks like a G, but it's a 9. All right, almost done. I'm tired now. That was number 57, okay? I'm going to do number 60. Let me do number 60. 6.2, number 60, okay? Number 60. Number 60 says this. 8y squared minus 14y minus 15. 8y squared minus 14y minus 16 divided by 6y squared minus 11y minus 10. 6y squared minus 11y minus 10 divided by 4y squared minus 9y minus 9. 4y squared minus 9y minus 9 divided by, do number 60. 3y squared minus 7y minus 6. 3y squared minus 7y minus 6. Okay, so first, flip it over, multiply. So here, this is 8y squared minus 14y minus 16 divided by 6y squared minus 11y minus 10 times, this goes up, 3y squared minus 7y minus 6 divided by, this comes down, 4y squared minus 9y minus 9. And now I'm going to prime factor the top and prime factor the bottom. The top. In the top, look, I can take out, I believe, a 2. 2 times what? 4y squared minus 7y minus 8. Okay, that's this one. I'm not done with that one, okay? I need to factor that one. But I had to do that first. I think I can factor this one. Let's try to factor that one. So that one is a product of binomials. 3y times y. 6. 6 is 2 times 3. Make this a minus and a plus, and let's check. We're gonna check now. 3y times y is 3y squared, got it. Positive 2 times negative 3 is negative 6, got it. Outer is negative 9y. Inner is positive 2y. What's negative 9y plus 2y? Negative 7y. It works. This one, let's try that one. Okay. Try to factor that one. Let's try 3y times 2y for 6y squared. Okay. And let's try for 10, I'm going to try 5 times 2. 5 times 2. I'm going to put a 5 there, and I'm going to put a 2 there. And that's not going to work. I can tell you right away, that's not going to work. If I make this minus and plus, it's not going to work because look, 3y times 2y is 6y squared. That works. Negative 5 times 2 is negative 10. That also works. But look at outer. What's outer? Outer is 6y. Inner is minus 10y. 6y minus 10y is negative 4y. It doesn't work. How about if we change those two? Let's take the 5 and the 2 and let's interchange them. 2 and 5. Hey, that's gonna work. That's gonna work. Yay. Let's see. Except for the sign. Let's try it. Look, what's 3y times 2y? 6y squared. That works. What's negative 2 times 5? Negative 10. That works. What's outer? 15y. What's inner? Negative 4y. What's 15y minus 4y? 11y. But we need a negative 11y. No problem. Let's make this positive and let's make this negative, and that's gonna work. 6y squared minus 10, and then outer is negative 15y plus 4y is negative ny. That worked. How about this one? Shall I try 2y times 2y? And shall I try 3 times 3 and plus and minus? Do you think that's going to work? Maybe not. That's not going to work. But you know what? If this doesn't work, if you change them, this is not going to work. This combination is not going to work because look, 2y times 2y is 4y squared. 3 times negative 3 is negative 9. But look at outer. What's outer? Negative 6y. What's inner? Positive 6y. They cancel each other. So this can't possibly work. So let's try a different combination. I'm going to try a 4 times a y is 4y squared. A 3 times negative 3 is negative 9. What's outer? Outer is what? Negative 12y. Negative 12y plus 3y. What's negative 12y plus 3y? Negative 9y. That works. Okay, don't forget, we're not done with this one, okay? We're not done with that one. Okay? But can we cancel anything right now? Sure we can. We can cancel this 3y plus 2 and this 3y plus 2, and we can cancel this y minus 3 and this y minus 3. Yes, we can cancel them. Okay, but we're not done. We're not done. So that one went away and that one went away, not those two. Here's the problem. Here's my mistake. Instead of writing minus 15, I wrote minus 16. So I'm going to change this to minus 15, okay? That messed up everything. Made a mistake. When I wrote it down, I made a mistake. So this one does not become this anymore. Okay? This one here, I did it again here. Write it in red so you guys can see my mistake. My only mistake was writing this 16 when I should have wrote it a 15. So that's my mistake right there, my mistake. Okay, I factor this one and it's right there. I factor this one and it's right there. I factor that one and it's here. Let me factor this one, okay? Everything's fine. Let me factor this one, okay? So let me go back. Okay, so here's my mistake. Instead of writing a minus 15, I wrote 16, my mistake. But I'm gonna fix it right now. So I'm minus 15, so I factor this one. I flipped it over and became multiplication. I factor that one is right there. This one has been factored there. This one has been factored there. I just need to factor that one. That's all I have to do. That was my mistake. I'm going to factor this one. Okay. 4y times y. Okay. And then 3 times 5. No. You see this 4y times 2y. There you go. Yes, so 4y times 2y is 8y squared, and 3 times 5 is 15, and I'm gonna make this a minus, and a plus. And there we go, guys. Okay. So this one cancels that one. This one cancels that one. This one cancels that one. And this one cancels that one. And what do we get? A 1. Okay. All right, I'm gonna stop here. Okay, this was section 6.1 and 6.2. Okay, thank you very much. I shall see you soon.